All right, so it's recording now. Okay. Just a little side note. I was talking actually with one of my, you've heard me say this, and in our class, and I was talking with one of my pre-calculus students that's not in honors about this morning. Is I didn't ever used to give the IOU chart, and I don't think I ever will again. The past few years I've given it just because people sort of like it, but I think it actually stagnates your learning and doesn't help as much as I hope. The 1, 2, 3 chart, y'all were really fast on that quiz just now. That you know that we actually do the quote unit circle. You just have all your numbers memorized for the first quadrant, and then you just transfer the signs to whatever quadrant that you need, so you don't have this big messy thing that you have to look at all the time. So hopefully when you get to something like sine of 7 pi over 6, you're at the place where automatically you know that's in the third quadrant where sine is negative 30-degree angle, and you move on with your life, that you can say it really fast. And it seemed to be. I thought the quiz went great. Okay, now what I really wanted to talk about was something that I'll keep reiterating. I'll get right back to you in just a second, Isabella. Is what I really do myself with the quadrantal angles. I have said many, many times, but I am not a fan of the IOU chart and kind of wished I hadn't given it to you because I think it slows you down, okay? When it's so fast, just to realize that sine of an angle is y over r, and cosine of an angle is x over r. And if you have a quadrantal angle, all you have is two of the three components. What I mean by that is if this is x and this is y and this is r, it's say 45 degrees, okay? If you're at 0 degrees, all you have is an x and an r of your circle. Do y'all see what I mean? There is no y. So I automatically know that the sign is 0. It's non-existent, okay? I actually see that as I get closer to 0, that y just disappears, or you can look at it at a point. Like if you want to use the unit circle, you could call it 1, 0. But whatever the radius of your circle is, let's say the radius is 7, then wouldn't this point be 7, 0? Automatically see your y component 0. And that's why cosine of 0 is x over r is 1. And tangent is y over x, it's 0. Okay, some of you also might see it visually. I kind of see it all in my head. Like I also see it on the graph. Like I see sine of 0 is 0 and cosine of 0 is 1. Do y'all see what I mean? Like I actually see that in my head. I see it all. Obviously, I'm not bragging. If I don't see it all, then something's wrong with your teacher. But I want you to see it. Like when somebody asks me for sine of 90 degrees or pi over 2, I see my y component is a 1-to-1 ratio with the radius. And if I need the cosine of pi over 2, I see there is no x component. Do y'all see there's nothing sideways about that? So my x component is 0. Or you can visually think to yourself real quickly that your point would be 0, 7 or 0, 1 or whatever. Now what would happen with tangent at pi over 2? Your 0 would be on the bottom. Okay? So I actually just use this in my head. And what I used to put on people's memo page is just like a little sample of a radius of 1. It doesn't matter what the radius is. Does everybody see why? When there's a lot of reasons that I don't, in a lot of ways I teach the unit circle, but there's no point in drawing all this other stuff over here when the first quadrant is just repeating itself over and over again. But I think in the past what I've done is I've used a radius of 1. But if the radius was 5, wouldn't everything still be, the ratios be the same? Do y'all see if the radius was 5, this would be 5, 0? And so on. And so if you start using this, I think you'll get faster at the quadrantal angles. Like I know sine is y over r, or opposite over hypotenuse. There is no opposite side. It's 0 at that moment. And then as you grow higher, your opposite side gets more and more close to your radius. And so in my brain, I'm doing all this y over r, y over x kind of stuff. Like I know tangent's undefined down here, y over x. Okay? I encourage that. That's what I see. And you might also. It seems like y'all are going pretty fast through that. I'm sorry, just ran right over what Isabella was asking or wanted to say.
I was just wondering if on the final will we be tested on any like straight up memo quiz stuff?
No, the whole reason you're doing that is so that you can use it. Well, I mean, yeah, I wouldn't mind asking you like sine of 7 pi over 6 in a multiple choice or short answer. But I mean, it's going to really hurt you if you don't know that when you're solving a trig equation or something like that. So, but you'll get a review so you'll know what it's like, an extensive review. And I mean, it's the same as what you've needed for my test or daily work or whatever. Okay.
Is the test going to be calculator or like partially calculator or no calculator?
Again, it doesn't really matter. I mean, I feel like that you can't. I mean, I'm not going to all of a sudden take the calculator away from my students, but a lot of you don't use it very much anyway. I feel like that you use it efficiently and in the way that I want you to, so I'm not concerned about it. Like if I ask for exact answers, your calculator's not going to do you any good anyway, you know, kind of thing. So I think we just go forward with how we've done it the whole year, where our class is using them to whatever degree you want to, but in the hands of somebody that doesn't know pre-calculus, it's sort of a worthless tool anyway. So I like the way that y'all use it and the ways that you think about things with technology. So I don't have a problem with it. There'll be I'll look over the exam once it's finalized and see if there may be some pages that I take the calculator away from you and say no calculator. But right now I don't foresee that. But that does happen in AP. So I wouldn't mind it happening on the exam. But I would never ask something that, I mean, we don't get ours out very much. I turned mine on today just to show you a button. So to me it's a non-issue, but to you it might not be. So we'll see as time goes on. But it's not going to be any more of an issue than it ever was before. Okay? All right, now that was just a side note. Let's move on to last night's homework. There was a typo that Brianna found, and some of you may not have even noticed it. There was one that had this weird a sub I was I think 1, and the ratio was e. The reason it's called ratio in geometric, and that had to have been a typo. A sub I, there was nothing to even like fill in for I. They didn't give you any other information. So like the whole rest of the section, it must have just been a sub 1. What number was that? 23. All right, so your first term is 1, and 1 times e is e. E times e is e squared. E squared times e is e cubed. I don't know how far we had to go. But girls, remember e is a number, 2.71a. You can multiply by e all day long. Well, we do a lot with e, okay? We'll study it a little more. You've seen it before, I hope.
It's Euler's.
Euler's number, yes. Which looks like Euler's, but it actually is pronounced Euler's. And it's like nature's base of growth. It has a lot to do with exponential growth, which, by the way, I wanted to say this before we go on. I never even got a chance to ask you if you had any questions, but now I'm on a roll, so I'll come back for questions. If you have a sub n is equal to a sub 1 plus n minus 1 times d. Hopefully, and somebody's already said this in class, can y'all see that that would be linear growth? All right, if I graph 3 plus 3 is 6 plus 3 is 9 plus 3 is 12. If I graph my first term, it's 3. My second term is 6. My next term is 9. My next term is 12. Can you see you're going up 3 and over? Up 3 and over? All right, so I'm kind of like moving through this really fast, but do you see you have a y-intercept? And you have a slope? So it's real important to know that arithmetic growth is always linear growth because you're adding the same thing every time. Does that make sense? Okay. So arithmetic is linear growth. And somebody's already, I think, noticed what geometric is. What's geometric? Exponential growth. And so that is important that we address that. Like if I have 1 times 3 is 3 times 3 is 9 times 3 is 27, you can actually see exponential growth there. If I plot them, My initial term is 1. My first term is 3. My second term, or really my third term, a sub 2 would be 9. And then 27. And it's going like that instead of like this. All right, so know that geometric is exponential growth. It's got an exponent in the formula. Okay? All right, questions on your homework?
Oh,
Okay, Elena?
I just forgot how to find, like, if it's, or no, if it's like, it was number 31. I forgot how to do it algebraically.
All right, 31. All right, 31, so you want the 12th term. So 31, you have a sub 1 is 6. Your ratio is 1/3. And I want the 12th term, so I'm just going to call that a sub 12.
Yeah.
I use common sense. There is a formula, but I think to myself, if I start at the first term and I multiply by 1/3, how many times to get to the 12th term? How am I going to get from the first term to the 12th term? 11 times. And that'll give me a sub 12.
So that's how you do it algebraically?
Yeah.
Oh.
Okay, now the formula is a sub n equals a sub 1 times r to the n minus 1. Hopefully everybody fully understands why that's the formula. If I want to get to the third term from the first term, here's the first term, and I want to get to the third term. That's why this n sub minus 1 is in both arithmetic and geometric. Is I already have the first term, whatever it is, and then don't you just have to multiply 2 more times to get to the third term? So to figure out how many I multiply by, you can subtract these two numbers if it doesn't start you at a sub 1. You can go, oh, well, how would I will do an example. But I've got to multiply by r 2 times, but how many terms are there? Actually, there's 3. So how many terms are there from a sub 15 to a sub 30? There are 16 terms. Y'all okay with that? If you're not okay with that, you can kind of amp it down a little bit. How many are there from 15, 16, 17? There's 3 terms, right? So you can subtract them, but don't forget that you've also got that first term that you started with. Now, how many r's do you need to multiply to get from 15 to 17? 2. So you can just subtract to find out how many r's you need. To get from 30 to 15, you already have a sub 15, so you need 15 more to get to 30. Okay? So on the heels of that, let's do one that I was asked about some this weekend and this morning. Let's go to number 45. 45 was a sub 2 is negative 18. A sub 5 is 2/3. And we want the 6th term, a sub 6. Okay? And I started getting questions about this sometime over the weekend. And so I thought I probably should go over it in light of some more questions I got about it this morning. All right, if you're starting at the second term, you never need to find the first term unless someone asks you for it. So that's why I was really a big promoter of common sense. And you are using the formula. But anyway, if I have the second term, how many r's do I have to multiply by to get to the 5th term? 3. And I know that the 5th term is 2/3. So you see, common sense-wise, I'm saying, oh, I started here. I multiplied by r times r to get that number. And I am sort of using the formula, but the formula's got an a sub 1 in it. To me, that just means wherever you're starting me, I'm going to get to the other place. Okay? And then I would multiply by negative 1 over 18. That gives me r cubed, and 2 goes into 18 9 times. I get negative 1/27. If you cube root that, you get r is negative 1/3. And so to find the 6th term, you don't have to go back to the first term. You can start at the second term, which is negative 18, and multiply by negative 1/3 how many times to get from the second term to the 6th term?
Oh, 6 4.
4 times. To get from the second term to the sixth term, you can do that to the fourth power. I'll go on and finish it. This is negative 18 times 1 over 81. 9 goes into this 2 times. So you should have gotten negative 2 over 9, I'm guessing. I didn't check the answers on this, but is that what it had? Okay. Again, a big fan of common sense. If you're tied to that formula, you have to do a little more work. You feel like you've got to go back and find a sub 1. Okay? Zaina?
But if you were to stick with the formula, is it just like less of a chance of like messing up? Like
No, because we're both using the formula, and especially for someone like you with so much common sense, I think there's more of a chance of you fumbling around with the formula than actually thoroughly understanding what you're doing. I would say this, I talked to somebody about this morning, it may be if you're someone like you, Zane, is using the formula. If you're given a sub 2 and a sub 5, some people kind of mentally shift that back to a sub 1, like they shift them all back however far and then use the formula. But don't forget where you are in the place. If your homework's going okay, I'm not going to mess with that unless you like something that I'm saying better. Okay? Here's what I'm talking about. Let's work this one. Let's say I have a sub 22 is equal to 4. And a sub 26 is 18. Okay? And you'd have to be told this was geometric because I would work it very different from arithmetic. Or not very. I would work it somewhat different than arithmetic. So let's say this one's geometric. All right, so my formula is a sub n equals a sub 1 times r to the n minus 1. Okay? Which I'm going, what would I do here? I've seen people that kind of do transformations and move all of this back and call this a sub 1 and call this like a sub 4 or whatever it would be. To me, that's, you might even lose where you are in that. You've got to find a sub, let's say I want to find a sub 6 here, okay? So say this was a test or homework, or exam question, and we want to find a sub 6. So what I would think to myself, oh, you just told me it was geometric. That means I started at 4. I multiplied by some ratio. How am I going to get from 22 to 26? 4 times. And I got 18 when I did that. Do y'all see what I'm saying? I started at the 22nd term, which is 4, 23, 24, 25, 26. And I multiplied by something 1, 2, 3, 4 times. By the way, there's a few reasons why I chose this one. Okay? Now I'll divide by 4. And I believe that gives me 9 halves equals r to the 4th. And I guess I should have thought ahead and to see what my ratio would be. Because this isn't one that you would recognize. You would then have to use decimals. So I guess we've gone this far. Let's keep going. So it's the 4th root of 9 halves, whatever the heck that is, okay? Trying to think if I can even simplify that. If it was 9/4, I could reduce it to some sort of square root, but I'll just use the 4th root of 9 halves. So if I say 4 times, well, let's just look at it. 4 times the 4th root of 9 halves, whatever decimal that is, to the 4th power. Do you see what you would end up with? The 4th root of 9 halves to the 4th power would just be 9 halves. 2 goes into 4 2 times, and you would indeed get 18 for the 26th term. Now, what would we do about the 6th term, though? So let me pause, and let's get that number on our calculator. All right, so, sorry. Oh, still not letting me do it. I'll just do it here. Sorry. All right, so I'm going to take, let's talk a little bit about your Algebra 2. If I take 9/2 and I want the fourth root of it, there is a fourth root key that I hate going to that menu. It looks weird and it's kind of cumbersome.
Go to the math.
So I'm going to raise it to the 1/4 power. Do y'all understand that's the fourth root? Okay, back to your algebra. So that would be the fourth root. Okay? And so that's my ratio. If I take 4 times that ratio to the 4th power, I should get 18. Now let's see how I can find a sub 6. So first of all, let's write it down. All right, so how am I going to find a sub 6? I can say to get from a sub 6, I'm going to take the fourth root of 9/2. How many times to get to the 22nd term? 16 times, so this is to the 16th power, and that should give me 4. Do you see how I'm using common sense to do that? Let me get the page up here. All right, so if I'm looking for a sub 6, it's back here somewhere. I've got to multiply by the ratio 16 times to get to a number that I know. So a sub 6 should end up being 4 divided by the fourth root of 9/2 to the 16th power, okay? Which I could do on my calculator because that would be really ugly without it. So I'm going to say, I forgot what I'm saying. What am I saying?
That to the 16th.
4 divided by that to the 16th power. So I'm going to say 4 divided by my ratio. Yeah, it's probably really, really small. So I'm going to bring that down there to the 16th power. So is that what a lot of you got?
Yeah.
Okay. Seemed like there was something else I was going to do with that, and I don't know what it is. All right, Chloe.
Instead of dividing by 4, I just raised to the negative 16th power.
That's fine. Did that work?
Yeah.
Because you're dividing by it. Yeah, that's fine.
Can you just repeat where the 16 came from?
We were trying to get from the 6th term to the 22nd term.
Oh, right.
Like, I'm going to go with something that I know. That's why when Zane and I were talking about the formulas, it's just got a sub 1 in it. And I just never even want to know right now what a sub 1 is. If I insist on using the formula, I got to backtrack at some point and find a sub 1. I want to know how to move from term to term. Did I answer your questions?
Yeah.
Okay. Katie?
If on a test or quiz we had to use the decimal to get rid of, should we use the one from our calculator or around?
It's not going to hurt to write down what your calculator says. That's never going to hurt. But I'll usually require 3 decimal places. If I need more, I'll say it. If I don't say anything in AP and in this class, I want 3. Okay? That's a good question. And I'll take it. I like to model what will happen in AP and SAT. On the grid ends, I'll take truncate. They take truncated or rounded.
Okay.
So you could do either one there.
But like when we're calculating it, should we use the value, like the 1.456 or like, etc. from the calculator, or can we just use 1.456?
Oh no, don't use 1.456. Thank you. Use like as many decimals as they give you. Because even that is a rounded off number. So you don't want to round it off more. You can start to fall forward. Don't ever use a rounded off number within your calculations. Okay?
Thank you.
All right. Now watch this. Every eye up here. Okay? Because what would happen if I took 4 and I multiplied by negative 9/2 what is it, to the 4th power? That's not what I want, I'm sorry. Let me go back and look at what I want. 4. Oh, it's the 4th root. Okay, so. All right, so I'm going to say 4 times negative 9/2. I wonder if I'm going to get an error here. We'll see. Yeah, it's not giving it to me. Let me show you what I'm trying to do here. And actually to show you, let me pause for a minute and say that this answer is really only 50% correct. But this kind of goes back to Rebecca's question. You're going to have a hard time fighting with your calculator to give you a root of a negative number, okay? And I'll talk about that in just a minute. But actually, when I take the fourth root or any even root, everybody look up here. When you take, and it probably happened in your homework, we'll see. When you take the fourth root or any even root, you really should say plus or minus. So my ratio is really the positive fourth root of 9/2 and the negative fourth root of 9/2. I'll make up one that comes out a little bit nicer in just a minute. But if you multiply by the negative fourth root of 9/2, which I just think I maybe didn't type it into my calculator correctly, but I should still end up with 18. So let me go back and look at this, at what I typed in. Oh, and I didn't raise it to the fourth power. So let me copy it down. I was asking it to take the fourth root of a negative number. So let's see. So I'm going to say 4 times. Oh, I know what I'll do. I'll take the fourth root. All right, everybody watch. Watch, watch, watch. Negative. I'm going to pull this number down. And I'm going to raise it to the fourth power. Now, what just happened, Katie, this also answers your question. Look right here. That's my ratio. We had gotten this number with the fourth root of 9/2. But I just used the negative fourth root of 9/2, and I also got 18. So let's pause for a minute. You remember how I said this itself is a rounded off number? So since it's rounded off, when I redo it this way with this instead of the fraction, it's having a hard time calling it a flat out 18. But if you round it to 3 decimal places, do you see that would round up to 18?
Yeah.
Okay. Point being, in an honors class, I don't really mind having messy numbers. But when you take an even root, okay, I'm doing it in yellow so you really see it. When you take an even root, you better do plus or minus. Your brain's got to be in gear, all right? So watch this. Let me be a little bit more intentional about it. I don't know why it's not letting me go to this. And we'll do a little bit nicer number. Let's say if I have a sub 3 is 2. And a sub 8 is I think 32 is going to get it. All right, let's find the ratio. So I'm going to say I started at a sub 2. I multiplied by some ratio. Oh, I want this to be a sub 7. All right, so how many times did I multiply by the ratio? 4 times, and I got 32. So I get 16 as r to the 4th. So what do you think r is? R is 2 or negative 2. Girls, everybody better watch. R could have been 2 or negative 2. Let me list those terms. A sub 3 is 2. A sub 4, A sub 5, A sub 6, A sub 7 has got to land on 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, check. What if I multiply by negative 2? 2 times negative 2 is negative 4. What's negative 4 times negative 2? Positive 8. What's 8 times negative 2? Negative 16. Negative 16 times negative 2 is 32. They're both equally correct. With a calculator, if you take the fourth root of 16, it's only going to tell you 2. You've got to be on guard on geometric for that plus or minus when you take an even root. We think of it a little more on the square root, but even on a fourth root, it's very important. Okay? All right, now, a couple of more things before we go today. In the next class, I'll show you, well, I'll go on and show you here. And you can, not something you'd really use right now, but I think I kind of showed you at the end of the last class. If you want to pull up some sigmas on your calculator to check some answers or whatever, you can go to math, you can go to number, and it's down, you want sum. I always forget where it is because I don't use it very much. Well, I thought it was, maybe it's just under math. Hang on. It's like 0, isn't it? Yeah. So it's math 0 on most calculators. Some of you, it depends on your operating system. Okay?
Really like 2 equations.
Reminds me of how do you get it to
I don't know what that is. We'll play around with it, Lily. It's not something you'll use yet. I need to update your operating system. Hey, girls, listen. Okay, but y'all listen up. And stay quiet for another 13 seconds. What we're already finding, some people that push math 0 don't get this picture. And some people get more than that picture. Lily got 2 equations, and Danielle didn't even get that symbol. Okay, I mean, she got the symbol, but not that notation. We need to check. Pietro, Michaela, y'all listen. You might need me to update your operating system. And if you don't get it done pretty soon, it could start to hurt you like as you head toward calculus. So at some point next class, I'll write myself a note. We need to all check and make sure you get this exact thing on your calculator. Homework's going to be more on geometric. Today I didn't answer many homework questions because of our Kahoot, I guess. But we'll reserve a time to answer a lot of homework questions. Homework will be on geometric.